Alright, class. So this is a very quick and short but sweet introduction to the empirical rule. And what I would need you to understand is the empirical rule is also known as the 68, 95, 99.7% rule. Okay? The reason for that is that when you look at a normal distribution, now this only applies to the this is to the standard normal distribution. And the other thing I want to make note is you need to understand that this is based on a diagram that basically focuses on the mean and the standard deviation as it relates to the z-score. Okay, so the z-score is the score minus the average divided by a standard deviation of some sort. That's what we call a z-score. So this refers back to the standard normal distribution. Smack in the center is what we call mu. Mu is another way we refer to the mean. So you might see this as a notation. This is the same thing conceptually. Just remember the standard deviation is different for a population versus a sample. So this would relate to the sample and this would relate to the population. So it's basically the same calculation, just, you know, this is the standard deviation for the population, that's the standard or the mean for a population. Where this is actually known as S sub x. So I just put standard deviation SD. Alright, so the mean is in the middle. We assume z to be 0 when whatever value is equal to the mean. Every time you go up a deviation, so this will become +1, +2 z-score, and +3 z-score, just to stop, and there are more at the end. So this is z equal to 1, z equal to 2, z equal to 3. Okay? On the opposite end of the spectrum, I have z is equal to -1, z is equal to -2, and z is equal to -3. And obviously there are other values that extend. That's why this is called asymptote, if you remember. Asymptotic at the end, where this line never touches this line, okay? And same on this side. So the ends are asymptotic. What you need to remember is, as far as 68, that refers to the values of the percentage of the population. If it is normally distributed, 68% of this population is going to fall between the -1 z-score and the +1 z-score. So it's between here and here. All of this is 68%. So basically 34% on this side and 34% on this side. Okay? Now, the 95% refers to everything inclusive of this, obviously, and then we're adding those percentages all the way in here. And I don't want to cover up the yellow because I want you to understand in the yellow specifically, that's all the 68%. But this all encompasses all of this all the way to the 2, from -2 to +2. All of that is 95% of the data. Okay? So obviously if we take 95% and we take away 64, we're left with 31, which if we divide in half is approximately, I'm sorry, I think I did this wrong. So 95% minus the 68%, that leaves us 27%, divided in half, puts us at about 13.5 on either side. So that means that in this little nook between here and here, we have 13.5% of the data. And in this little nook, we have 13.5% of the data, meaning between the positive 1, the positive 2 z-score, the negative 1, and the negative 2 z-score. Okay, and lastly, I'll do this in the lavender color. The 99.7% basically encompasses all of this area. So, I'm sorry, I went too far. I know it's taking so long. I'm trying to erase the lavender because I went too far on the eraser. Maybe I'll just erase that part. There we go. Alright. So anyway. So just from the negative 3 to the positive 3, meaning that all of this area from the negative 3 to the positive 3 is 99.7% of the data. Okay? So if I took, again, our 99.7 and took away from it 95%, which we already covered, that leaves us 0.047, which I divide in half, is approximately point. So if I divide this by 100, it's approximately 2.35% on this side and approximately 2.35% on this side. Okay? So just remember that that's how it works. And if I gave you an example, so let's say I had a mu that was 100 and a sigma that was 15, if I am drawing a normal distribution, in this case, I would, okay, so we draw our base, we draw our approximately normal distribution. The center is where the mean is residing, so this would be 100, and this will go up 115, 130, 145 on this side, because you're going up plus 15. So this is like plus 15 again, and plus 15 again. On the left side of this, we're subtracting 15. So if the mean is 100, take away 15, the first value at z of -1 would be, in this case, 85. Take away another 15. Now we're at a z-score of -2, right? Which is, in this case, 70. And if I take away another 15, then I'm at 55 for this. So this is 55. And that's an equivalent of z-score of 3. Because here I'm taking away 15 from the 100 and repeating the process accordingly. So the way the notation looks, they do the z-score in terms of, if this is mu plus sigma, this is mu plus twice sigma, and this is the mean plus 3 times sigma, right? So mu's mean, same thing, right? Over here, this is mu minus sigma, this is mu minus twice sigma, and this is mu minus 3 times sigma. Okay, where sigma is the standard deviation for the population, mu is the mean for the population. Alright, so if these were your results for a score, this is how the data is split up. So I would say 68% of the data is between a score of 85 to 115, which is the equivalent of z-score of -1 to +1, right? And if I said applying the 95%, 95% of the data means a z from -2 to +2, which means scores between 70 and 130. So if you score between 70 and 130, you're part of the 95%. And then lastly, the 99.7%, which is where z falls between -3 to +3, and so in this case the scores from 55 to 145. Okay, So using the z-score, which is the score minus mu over the standard deviation, all right, and so if your score was say 121 and you want to know what that z-score is, then you would substitute in 121 minus 100 divided by 15. That gives you 12 over 15 as a value, and then you just find out 12 divided by 15, that's approximately a z-score equal to 0.8. Alright? Now there's a couple of tricks that I want to show you, which I'm actually going to show you in Excel. So go ahead and pop your Excel open. And I'm just going to show you this because this is going to help you a lot in the homework, I think. So, when you go to Excel, there are a couple of functions that I want you to learn because they will come in very handy. And one of them is equals norm. Okay, and I want you to notice that I'm looking at norm S. You see how it has an S there, dist. Norm S dist, say my z-score is 1.2. And I want to know the area behind that it represents. So I'm looking at a diagram that's sitting as such. And so if my z-score of 0 is right here, here's 0, here's 1, here's 2, and we looked up a z-score, so if my z-score is equal to 1.2, I'm somewhere in here, right? And so the area that you see there is this area. So I'm above 88% of the individuals. Obviously there's a little bit of decimal equivalent there. So that's how many people I'm above. So this is where I rank, right? And anything above here is simply 1 minus that. So if I did this equals 1 minus that number, this is approximately 1 minus the 0.88493, that means that there were approximately 11.51 people, percent of the people that scored above me. So that's how you find the percent. You put in the z-score. But remember, z-score only reports what's behind it, okay, not what's above it. So to get what's above it, you have to use 1 minus, okay? Now, let's say they tell you the actual value. They gave you the percentage. So if they give you the percentage, you're going to use equals norm at inverse, which is the one right below it. So you see I'm using norm S inverse. I'm going to double click on that. So let's say the probability was again 0.88493. So I'm going to use the same number so you can see the correlation. See how the answer is 1.1999, which, if I simplify it, so I'm going to simplify it, see how it turns to 1.2 immediately? And that is exactly what the z-score is. So that's the connection between them. If I do the area below it, or above it, so in this case I would do the same thing, equals norm S inverse. And so here's norm S inverse. And I'm going to put in the probability of 0.1151. See how that gives me the negative equivalent? In this case, because it's above, I would do equals 1 plus this number, and I get something's not right here. 1 second. So I'm trying to do norm S inverse. This was norm S inverse of 11. This is norm S inverse of 0.88. Here I'm doing norm S inverse of 11.51. So I'm trying to find the z-score above it. But if you notice, it's giving me the z-score below it, which is the negative 1.2. So forget about that. That actually gives you the opposite answer. You just have to do 1 minus that value to obtain the z-score. Because the z-score only reports from here back. Okay? Alright, well I hope this little video has been helpful, and if you have further questions, just ask.